All right, so we start. So we were talking about MDPs, and how many of you remember? How many of you can write Bellman equations on your own right now? एक बार raise your hands. How many of you can write Bellman equations right now? So just try it once. I'll not call you here, of course, but just try it once. Rest of the course, we won't do even a single lecture without those two equations. So this is what we had. How do you write V star S? So what is the interpretation of V star S? No, what is the interpretation of V star S? How do I understand it? What does it mean? So attendance नहीं शुरू की है तो शुरू हो गई है नहीं एक मिनट रुक जाओ देखें. So there are some papers इनका यूज कर लेते हैं. So coming back to this, what is the interpretation of V star S? No, I don't know what is Q state. My question is what इतनी गर्मी हो रखी है क्या? Okay. Huh? Right. So V star S, if you play optimally from that particular state S, then the maximum, I mean, what is V star S? If you take optimal policy in state S, V star S is going to give you the maximum expected utility. Okay? Why expected? Because we don't really control the trajectory. It depends on a lot of other things too. Next. And how was V star S written? V star, so this was written as what an agent can do in this state S. So an agent can take all the actions. So V star S depends on which action am I taking and then which Q state I go to. Then how do we write that Q star SA? What is Q star SA? Right. So which action gives you the what thing? So what is QSA? What is a Q state, by the way?
that's taking its decision. Now, am I deciding what to do?
Right. So Q state is not an actual state. Actual states are only these blue guys. What is this guy? Agent has taken its action. Now agent has absolutely no control. And then the environment, so basically I end up being in state S prime because of the kind of environment I have. If I have a deterministic environment, then I know for sure if I am going to take this action, I'll end up in S prime. But if my environment is not deterministic, I don't really know. If I take north, I might end up in east or west. Okay. All right. So what was the equation for Q star SA? So don't go for summation. Start with inside out. Right now you are at S. So right now you are at S. You are going to S prime. So reward from S to S prime when you take action A. This is the scalar that you are going to get for this step, the current step. What was the additional term? Plus V star S prime. Okay, V star S prime, because V star S prime is what? My maximum expected utility if I start doing the best from S prime. But now future is discounted, because we see if you are going to do something in future, then this has to be multiplied with gamma. Okay, so R plus gamma times V star S prime. Now that is not the only path that you can take from here to here, right? You have multiple actions. So how do I bring that T thing into picture? So you have taken this particular action. Now what? So environment can basically send you. So let's say these are three things. You took action north. It can send you to north, but it can also send you to east and west. Okay. So then you have to take into account what? The probability of going north, the probability of going east, the probability of going west. Take a weighted sum of everything, and then that is what Q star S is going to give you. Okay. So we were here. Okay. All right. So we continue from here now. Racing search tree. What are we going to do in this? How many of you are going through Berkeley lectures? कोई है जिसने पूरे Berkeley lectures देखे हैं अभी तक के? मिड-टर्म 1 तक के 2-3 तो थे. देखो, अपनी class is fine, but those lectures they are really worth, right? Go through them. Fine, coming back to this. So, by the way, I have uploaded videos, I have just not made them public yet. आज हो जाएगा. Okay? Last के 2-3 I think रह गए होंगे, but other than that, fine. So, coming back to this. How do I do this? What do I do in this? How is this what was the game here? You start in slow state. In slow state you have how many actions available? 2. What are they? You can move slow, you can move fast. So if you move slow, you take that path. If you move fast, you take this one. Now if you see, this subtree is same as this subtree, because here top of it you still have just slow. Okay, but this subtree is a bit different. All right, so we continue with this. What is happening here now? First of all, tell me if this is an infinite tree. Why so? Because? Right, so you can keep on moving, there is nothing that stops you from doing this except maybe, so if you reach here, then there is no subtree down there, right? If you reach here, then game is over. So my only goal is, I should not go, sorry, that was a wrong statement, that my only goal is to not reach here. My goal is to do what? Maximize. No, what was that thing? Score. So what is that score? Maximize expected utility. So now, this tree goes really infinite. Can I use expectmax to solve this? See, all these things that we have been doing until now, can you use expectmax to solve it? State, chance, this is what expectmax was. Okay, so yes, you can. Okay, now, okay, so just shifted, I think, right? What happens here now? So it says we are doing way too much work with expectmax. Problem is that the states are repeated. If they were different, then it's okay, because then in that case you need to do that much work. But if things are repeated, so remember those things when we were talking about, during search days as well. You can have a very small number of states, but you can still have infinite search tree, right? So you have a very small number of states, but you have a infinite search tree because everything is repeated. So only compute needed quantity. So only compute the needed quantities once. Problem is tree goes on forever. Do a depth limited computation, but with increasing depths until change is small. Deep parts of the tree eventually don't matter if gamma is less than 1. So gamma less than 1, it actually helps us make algorithms converge. What will happen if gamma is equal to 1 or if there is no discount? Sorry? So if gamma is less than 1, what will happen to rewards down there in, let's say, 1000 level? 0, right? So that is how these guys help us in almost all these situations. So, to help our algorithm converge. So tree goes on forever. We need to do a depth limited computation, but with increasing depth until change is small. So then what we are coming to? What is the transition we are making from here to next slide? Limited depth now. So we are not going to have an infinite tree, we are going to truncate it somewhere. Okay. So key idea is time limited values. Now we are coming to something. So now we are actually, earlier we had just equations. Now we are converging to kind of an algorithm. Okay. Key idea is time limited values. Define Vk as to be optimal value of S if the game ends in k more time steps. Equivalently, what a depth k expectmax would give. So, एक बार ये छोड़ो. Define Vk to be the optimal value of S if the game ends in k more time steps. What is this? So let's say if we are talking about V2, what are we doing here? We take 2 steps and truncate this, right? So this is the tree that we are having. Equivalently, this is what a depth k expectmax would give from S, okay? So this is just V2, okay? Okay, what was happening in this? कितने लोगों ने जाके वो numbers की कोशिश की? So
So, likewise in first iteration, zero iteration, we have 0 points.
Mhm.
We have not started yet.
Right?
After one by one iteration, when we move forward, so we have the plus one is the positive point, minus one we want to get, and सर एक point जैसे से increase होता चलेगा, तो उसकी जो हमें Q state values है,
Right.
values से उसका maximum Q state जो है उसका लेना होगा, एक Q star निकालना होगा.
Right.
एक एक वैल्यू जैसे लाइक हमने फर्स्ट पॉइंट जो होगा 1 के पास मतलब 0.85 आएगा. हमने चार Q state वैल्यूज पहले ली, उसमें से जो मैक्सिमम वैल्यू है Q star वो 0.85. दैन मूविंग फॉरवर्ड एक एक करके हम इंक्रीज करते जाएंगे, तो लास्ट पॉइंट होगा सबसे कॉर्नर वाला, उसका Q star वैल्यू होगी सबसे लेस होगी, बिकॉज़ वो आपके मैक्सिमम जो आउटपुट है आपका उससे सबसे दूर है.
Okay. All right. So let's talk about this now. उससे पहले we have just talked about this. Any questions on this slide? What are we trying to do? मैंने क्या बोला था कि पिछली स्लाइड से इसमें क्या ट्रांजिशन है? So we are going to limit things now, not infinite tree. Okay? No infinite that gives us. See, the moment you go from infinite to finite, you can talk about algorithms. You can't talk about algorithms if you have a infinite structure. Okay? This one? So what is VK? Yeah, that's a good thing. So let's understand what is this VKS. What is K? Define VKS to be the optimal value of S if the game ends in K more time steps. Will our strategies change? But if you are given less time versus if you are given more time, will our strategies change? They do, right? Strategies in the sense, what am I supposed to achieve? What will I be able to achieve? So define VKS to be the optimal value of S if the game ends in K more time steps. So here, let's say it ends in just 2 time steps. Achha, we'll do that in the last if we reach there today. But if I give you just 1 time step, what will you do? Will your strategy be different from, will your strategy for 1 time stamp be different from 2 time stamps? You can play only 2 moves. So let's say you start in slow, you take slow and you take slow again. That's it, game over. Now, or you start here, so whatever points you got, you got. Now let's say some other player starts slow, goes fast and takes another action, slow, fast, whatever. So then that person will get a different utility, different set of rewards. So let's say whosoever gets the maximum, we declare that as the winner. So if I allow you 2 steps and in contrast, if I allow you just 1 step, what might be your strategies? So can I actually go to this state if I allow you just 1 time step? You can't even go to the overheated state, right? So things actually change depending on the depth you are exploring. So when you are at K equal to 0, what happens in this case? Game ends, you are not allowed to do anything. So if you are not allowed to do anything, why is this all zeros? You are not allowed to do anything. So not even allowed to take just 1 step. So everything 0. What happens here now? So what can I do in just 1 step and still get rewards? Of course, exit is the only thing. So these are the 2 states where I can get something in just 1 time step. If I am here, I get +1. If I am here, I get -1. Here I have no choice, but I have to take an exit, and which will give me -1. Okay, what do I do next? I think this is where we left. Now let's say you have just 2 timestamps. What is the best thing you can do?
We can start with the step which is just above the line.
In 2 states, so at depth 2, where all can I go?
That will be set with one step.
And we are looking for optimal play.
I will just go through the exit.
Where? यहाँ पे?
वहाँ से भी exit पे जाऊँगा.
Okay. Anywhere else? So any other state which is possible at level 2? देखो, let's go back. Any state which is possible and will give me non-zero reward if I just play for 0 timestamp, I won't be able to do anything, I won't be able to get anything. But if I play for 1 timestamp, then I can exit from these 2 states, so there I am allowed to play. Here. So why this 0.72? I mean, I don't understand these numbers actually, but why 0.72? These are not Q values, these are V states, right? So these are V values, not Q values. So how do you get 0.72? 0.9 into 0.8 is 0.72, nice. So how do I get it? देखो, अगर आप बोल रहे हो 0.9 into 0.8 which is right, but then how will you justify this now? So you were right when you said 0.9 into 0.8, that is right, but then how do I justify this? See, I am at depth 2, I am allowed to do only 2 things. What is the best set of actions I can do? I am here, from here go here, take exit, 2 steps. What is the probability of going this side if I take this side? 0.8. Okay. What is this 0.9? This happens in the next step. So 0.8. What is this guy? Use Bellman equations and get me this 0.72. देखो V star equal to Q star SA. Fine. Second वाली equation पे आओ. Q star SA equal to summation S prime T S comma A comma S prime and then reward plus discounted values.
ये क्या होगा?
आप बताओ. Living reward is 0, so R of SA S prime is 0, that term is 0 plus gamma times VS. What is VS? Exit, और exit पे क्या V star value है? It is 1, we know. So 0 plus gamma is, so 0 plus gamma is 0.9 into 1. And now what? I have that summation sitting there. So I have this summation over S prime. I have summation over S prime. Okay. So what are the possible S primes if I just take north? I could have gone to east and west. So why is this? So do you think that is reflecting in this? Because कहां पे? जस्ट अ सेकेंड, देखो, आई एम जस्ट ट्राइंग टू रिमूव दिस गाय प्लस, सो 0.8 plus 0.1 times same thing plus okay, दोनों में जीरो, राइट, हाँ, so this 0 and this 0. Thank you. हाँ,
So मेरा R है, the reward
R is 0 right now in this case. हाँ,
R is defined as the reward I get from moving from S state to
S prime
by taking A action.
by taking action A, right,
S prime 1 है.
right.
So मतलब अगर मैं एकदम नीचे से start
S prime 1, wait, S prime 1 means
मतलब the reward I get should be 1 ना 0 क्यों होगा?
no, reward is 1, you get it only when you go here. Now from here if you take a right, if you end up right, R is 0 and your V is 0 here anyway.
इससे R तो Q star value रही है,
इससे R तो Q star value रही है.
0.7 Q star value होनी चाहिए.
So this is my Q star. What will be V star? So maximum of this is
So for example, these values that are written in the boxes 0.0 to 0.7 to 1 minus 1, these are all my V star, right? These are V star, and the discount is 0.9.
right.
And what is in R? Reward क्या है?
Living reward is 0.
For all states.
So no matter from where I travel, how much I travel, R is 0. Okay.
और living reward is 0 because there is a discount associated.
Living reward is 0 because you define it to be 0. If you define it to be non-zero, it will be non-zero, and then it will come to these equations. हाँ,
सर जो 0.72 वाली V star वैल्यू है, उस पॉइंट पे ये वैल्यू Q star की वैल्यू बार-बार कैलकुलेट होगी.
यहाँ पे अभी वाले केस में नो, this is what you have because you can just go to depth 2.
अगर अपने टैब पर आता है.
That's what we'll go in the next slide. हाँ,
What are these values 0.8 0.0?
so what are these values, guys? 0.8. So remember Bellman equations. What was the equation? Summation over S prime T S A S prime. What was T? This was the probability that if you are in S, you take action A and you reach to S prime. So here the probability that you will go here is 0.8. This side it is 0.1. That side it is 0.1.
These were
ये जो अपनी पुरानी वाली चल रही है वो वही चल रही है. Okay?
and here noise is like not used.
No, this noise is actually ये probabilities only. So noise 0.2 means 0.2 is the probability that whatever you were intending will not happen. Which in our case is I can go left with probability 0.1, right with probability 0.1. So this means 0.8 is the probability of happening what I wanted to do, which is if I take a north, I go north. More questions here? This is 0. So yeah. Done? आगे चलो. What happens here in this case now? Now you can recursively keep on doing that same thing and these numbers will keep on changing. Okay? I'll let you discuss whatever you are doing. कर लो एक बार.
Next like this 0 point
Done? अच्छा अब एक बार इधर बात है ना. सो कीप ऑन डूइंग दिस फॉर डिफरेंट डेप्थ्स एंड यू कीप ऑन चेंजिंग दीज नंबर्स. नाउ इफ यू सी k equal to 12 is this is not very different from k equal to 100. Maybe this has become so 0.42, 0.47. So this has become 0.43 and 0.48 in the remaining 88 iterations, right? So after some point it will converge. Converge because of what? It will converge because of these discount. If you don't have discounts, then things will not converge, right? Chalo. So computing time limited values. What happens here if you have infinite tree very deep down? V's will be 0. Okay? So that is our V0. So let's say if this particular tree is 1, 2, 3, 4, 5 depth. So 0, 1, 2, 3, 4. We can go all the way until V4. V0s are all zeros. Right? We are saying they are so deep down that their values is 0. Next. So if I know V0, can I compute V1? What were Bellman equations? Bellman equations will give me value of the current state in terms of the next ones. So if I know V0, can I compute V1? I can. If I know V1, can I compute V2 and so on? Okay? Alright. So this is what we have been talking about just. वैल्यू इटरेशन, ये जो नाम है ना, ये नाम अपने आप में बहुत इंपॉर्टेंट है. बिकॉज इन reinforcement learning you either do value iteration or you do policy iteration. So these, just to understand कि value iteration क्या होता है, it's an important thing to do. So what is value iteration? You are calculating Vk in terms of Vk plus 1, right? So that is your value iteration. You are computing n minus 1 in terms of, so what was, how were we doing it? We were computing, right? So algorithm will come anyway. So okay, you start from deep in the tree and come up, right? So this is the algorithm. So start with V0s, and which is 0, because no timestamps left means expected reward sum of 0. I don't understand this. If anybody of you can help me understand this.
Then we can't move forward because zero है हमारा.
Okay.
Zero है, so we can't move forward. मतलब reward zero है सारा, मतलब में सारा zero है.
Right.
That's why it's zero. We can't play this.
Start with V0s, which is 0. What does it mean? See, so if you don't have any step to play the game, you won't get a positive reward, you won't get a negative reward. It's all 0. Okay? Now, given a vector, so vector को भूल जाओ, अपने we just have single scalars. So, given Vk values, do one ply of expecting x from each state. What is this? What is this equation? This is same as expecting x. कैसे? कैसे? This is same as expecting max. This is what we have been doing. Right? So which part is expecting max here? What are these guys? Values at my next successors. You assign probabilities to them, take sum. This is what we have been doing for expecting max. Okay? And then you, what is this max over A? I take that action which maximizes this one. Huh? So let's go back. हाँ हाँ क्या बोले थे आप? So let me go back here. Give me, so these were the, what were these values? What were these values? V star. Now I am not interested in V star as such. Okay. Let's say if from here I go here, give me the value of this state now. Just compute. Zero कैसे? See, एक बात बताओ, ये सारी चीजें यहाँ पे ये जो numbers आए थे, why were these numbers here the way they were here? They were here because I took the section 0.8. I intend to take that one. Let's say if I go this one, what is the probability assigned to this section? I mean, so I want to take this action, right? So if I go in this direction, 0.8 into whatever that, will that number change and it will not be 0.72? If instead of taking this action, I take this action, will my V star change? V star will change, right? So why do we have 0.72 here? There is no other way in which I can play and get a better number than 0.72. I had other chances, I had other moves here possible too, but those are inferior compared to if I move in this direction. Okay?
If I move south, तो क्या value है?
कर लो कैलकुलेट
0.09 आ गई.
0 point whatever. Okay? So now coming back to this. Given vector of this के values, do one ply of expected max from each state. So वहां पे अपन क्यों पहुंचे थे? Because for vk plus 1x you can still have many values. If you go north, you may have a different v star. If you go east, you can have a different value, and so on. So you maximize, you take that action which maximizes this quantity and put that to vk plus 1, basically same as Bellman equations, but you have written it in a different manner. What are they? In this case, you are writing vk plus 1 in terms of vk. You have turned those equations into an algorithm, that's it. And repeat this until convergence. Complexity of each iteration is S square A, will converge to unique optimal values. So एक बार तो मेरे को ये समझा दो, मेरे को S square नहीं समझ में आया. हाँ, y s square, y a सबसे पहले आसान को हटाओ. So you are in state S. देखो, it says, एक बार इसको ढंग से पढ़ लो पहले इस बुलेट को. It says complexity of each iteration. What is each iteration? When you are given vk, you compute vk plus 1. तो अब बताओ, how is it a square a? I'm actually slower than I planned to be. But it's okay. These equations are important. Yes.
With every iteration,
Everybody is okay with A? A is the actions available in whichever state I am. Why S? Why should it be S into, so S into A? See, guys, when will S square come? When you have S on this side and S on this side. So this state, so how many S's here? S here, okay? So you can go, this pair S and S prime, this can come from any of the states S, this can come from any of the states. But in practice, will it go all the way to S? No, right? So this is the worst case thing. So, and in any state you can take action from this set. So this is the worst case time complexity. Now, will converge to unique optimal values. Approximations get refined towards optimal values. Policy may converge long before values do, but we don't read right now. When we talk about policies, we'll talk about that. By the way, just a second, policy may converge long before values do. ये अपन ने एग्जाम्पल देखा था, which case में? Let me go back again. I am talking about just this one line. What was that one line? Policies converge k equal to 11 है. एक बार बताओ, एक बार पॉलिसी देख लो. What is the policy? From here go left, take this path, take this path and take this path. So policy is fairly clear. I go to this one. Values changed. Policy change हुई? No. You go all the way from k equal to 11 to k equal to 100. Values still changed. So values still changed. Policy changed? No. So this is all that line is saying. So policy may converge long before values do, and this gives us motivation to talk about policy iteration now, because values converge much later, policies converge much earlier. So this is what value iteration is. Okay, ये कंप्यूट कर दो भाई वैल्यूज मेरे लिए. V0. V0 is all zeros if you say so. V1 इक्वेशन देखने की जरूरत नहीं है. V1 so V0 all zeros, everybody understands. V1 you said. So he says 210. Why 210? So talk about this state. अपन कौन सी वैल्यूज लिख रहे हैं? विच वैल्यूज आर वी राइटिंग डाउन? जीरोस क्या था? So no, fine, no time, but what were these zeros? You cannot have any reward, no utilities. Okay, what will happen if you are given just so? देखो, even a fifth or a maybe fourth class, fifth class student knows it. बस अपन ने इसको formalize कर रखा है, so we don't like it. You are given this game. उधर भूल जाओ, ये भूल जाओ. Just look at this. You are given this game, and you are supposed to make only one move. Okay, पहले when you are in this state, which will be that move? When you are in this state, which will be that move? And here you don't get to do anything. So let's say I am in this state. Shall I go fast? No. Okay, what should I do? Slow. What is the reward for action slow? 1. I am here. Game is over. I don't do anything. I don't receive anything. What about V1 when you are in slow? Only one chance. Which one gives you +2 reward? Fast. Whether you stay in cool, whether you go to warm, does not matter. You just take action fast and get 2. एक बार ये वाला कंप्यूट कराओगे. This is really involving a lot of things now. I really need help here, huh? Yes. 3. No, it's not that straightforward. Why? Now this equation will come into picture. Until now we did not need it. Yes. So probabilities. So let's say we talk about this particular one. I stay. So what are the things I can do? I can take 2 actions, slow and fast. Okay. Now what are the values I am going to get here? Use this equation. So what is Vk S prime? If I am here, no wait, if I am here, sorry, +1 and +2 not really. So we are not talking about any living rewards anymore. We are simply saying if you take this action slow, you get +1. You take action fast here, you get +2. And with probability 0.5 you go to this state, and with probability 0.5 you remain here. These guys are R. These, so देखो, these guys are R's, and ये जो अपन ने लिखा हुआ है, these guys are these. Now compute this. So यहां पे अपनी ट्री क्या बन रहा था स्लो पे? I can go to, so I can take slow, fast. Okay. Now what do I do? So if I go slow, give me this equation again. So this guy is 2. This guy is 2 plus, nahin, this is 2, nahin, 1. So just a sec. This must be, wait, likho. So let me write it here. R was 1. When I go from slow and so if I am in blue, then I take slow and fast. Okay. So I take slow. This is 1. Gamma is 1. Vk is 2. So what do I get here? 1 plus 2. Okay. Now एक बार इसको छोड़ते हैं. What about this guy? Fast. So if I am here, if I go fast, I get 2 plus V1 2 I'll take 2 plus plus right. Okay, so this is still 2. Now I have this 1 plus 2 and 2 plus 2. Okay, I am yet to resolve this guy. देखो, I am doing V2 equal to this thing. Okay, इसमें what are the things that are there? Vk is 2. Okay, what is TSAS prime? So if I start from slow, if I start from cool, I remain cool, so SA see, if I am cool, I take fast, I get reward 2, and why is Vk 2? Sorry? हाँ, thank you, thank you. Okay, so no, देखो एक सेकेंड, दिस इज ओके विद एवरीवन? चलो, तो दिस इज सेम एज दिस, जस्ट दैट आई एम टेकिंग फास्ट एंड गेटिंग रिवॉर्ड ऑफ 2. एम आई राइट? हाँ, see, I was here, I can take 2 actions, slow and fast. If I do slow, I get reward of 1 plus gamma times whatever Vk is. Vk is 2. If I go fast, I get reward of 2 plus whatever was here. 2, same as there. Huh? No, I am saying if this is 1 plus 2, then this will be 2 plus 2, simply because when I go slow, I get reward 1, when I get fast, I get reward 2. And this quantity is same for both. Right. Four plus, हाँ, right. Right, so we are yet to do this guy. So zero, no, this is not 0.5. Actually, I made a mistake. This should have been a chance node, है ना? That is the mistake, because this is the chance node. Now if from slow Right. So if these are chance nodes, I get 2 and 2 here. Probabilities of that chance node will be 1 by 2. Yeah. So this is, I am in blue state, I take 2 actions, slow and fast, I go to chance nodes, and now I am, yeah. So if I go to slow, I remain slow,
with probability 1.
right? And in this case, if I take fast with probability 1 by 2, 1 by 2 I go there. And this is where this guy will come in. I think I'll do this in the next class properly. है ना? चलो. Attendance? आज की क्लास तक. Thank you. हाँ? No. So post midterm 1. Okay? हाँ? A star का एक क्वेश्चन आएगा which I had said. So this is how exam will go. देखो, there will be one question. मैंने क्या लिखा था वो एक बार मेरे को टेक्स्ट याद दिलाना एग्जैक्ट. तो देखो ये गलत बात है, उसी से मैं पूछना चाहिए था बिकॉज एल्स इट इज अज्यूम्ड कि यू हैव अंडरस्टूड एंड यू हैव एक्सेप्टेड. कब की बात है, डेट बताना. 5th September. So एक सेकेंड, I will keep midterm 2 of 25 marks instead of 20. Now the aggregate of these marks will be sum of these two with maximum marks being 35 even if you get more. So there will be a question on A star, right? So total जो marks जो evaluate होंगे they are 40, but you can get max of 35. Okay? So if somebody जिसने A star पिछली बार भी कर दिया था and इस बार भी कर देते हैं, right? Fine, good that they know, but they don't get any advantage in terms of marks. But those जिन्होंने पिछली बार नहीं किया था, but इस बार कर देते हैं, so they can still get the complete marks from A star because वही एक disputed question था. Okay? चलो. एक सेकेंड.